students, in the previous videos we discussed how to solve the questions or how to find the inverse of the any given matrix. So what I discussed in the previous videos, for any matrix A, my dear students, first I will read the question. By using elementary transformation, find the inverse of the matrix. So this question was asked in June 2017 for 3 marks. Very important, my dear students. Definitely such type of questions will be there. So this question was asked in June 2017 Karnataka State Board in second PUC annual examinations. They asked these questions, and such questions will be asked definitely. So please try to practice such type of questions. So my dear students, in the previous videos I discussed for any given matrix, if I wanted to apply the elementary transformation. So what are elementary transformations and those all what are elementary transformations and how to apply that, all those conditions we discussed in the previous videos, but just I'll recall the things. So my dear students, if you have the any matrix A, to solve that matrix, to solve that matrix, I mean to find the inverse of the any matrix, first you should think whether you are applying the row operation, elementary row operations or column operation. You should decide. To decide that, my dear students, after deciding that, if you are applying the row operations, means you should write, my dear students, first you should write A is equals to I into A. If you wanted to apply the row operation, means the first step is you should write A is equals to I into A, and here whatever the given matrix is there, you should fill up here this. Instead of writing in the next, after writing A is equals to I into A, you should put the matrix A value, whatever they given to you, you should write here. And then, my dear students, I you should write it as the identity matrix. If the given matrix is of the order 2 cross 2, you should write the identity matrix as 1 0 0 1, and next here this you should write A as it is. You should not substitute the matrix value of this. Clear? So after writing this, my dear students, whatever A is nothing but here it is 1 to 2 minus 1. 2 minus 1. This is the matrix A given to you. I is the matrix I have substituted here, and next A is as it is. Now you should apply the row operation. So you should apply the row operation in such a way that in the LHS place you should get it as the identity matrix. Until you get the identity matrix, you should keep on. You should apply the row operations. Clear? What are row operations? Already I told you this. The operations is here this. You can interchange the any two rows. Clear? You can interchange the any two rows, and next to the any row you can multiply with the non-zero constant number. Clear? And next is, my dear students, for the any row, for the elements of the any row or column, you can add with the, here it is any rows corresponding rows, elements of the corresponding rows by multiplying k with that. This is like this. So these are the three operations you have for the row operations, elementary transformations you have. You can apply these any among these. So depending upon the situation, you should apply this and you should solve to get in the place of LHS. You should get it as the identity matrix. Clear? After converting this LHS as the identity matrix, and similarly whatever you are applying the operation, you should apply in the here in the RHS place also. After applying this, whatever you will get, you should compare with here, my dear students, A inverse into A, and now A is as it is. In the place of A inverse, whatever you have, that is your required A inverse. Like this you should solve. This is the just in brief I explained how to solve, how I will solve this question. Clear? For more information you can refer my previous videos. Now come to the question, my dear students. So here they given to you one matrix. First I'll write the given matrix as, here, my dear students, I should write it as, to use the elementary row operations we write, to use here, to use elementary operation, to use elementary operation, elementary, you can write it as elementary row operation, we write A is equals to I into A. Clear, my questions. Now I'll substitute the A matrix value. So that is 1, 2, 2 minus 1. And this is equals to, what is A here? A is nothing but the identity matrix 1, 0, 0, 1, and this A is as it is. Clear? And my dear students, what I told in the previous videos, so I should convert this matrix as identity matrix. To convert this matrix as identity matrix, we should go in this order, like this. First element, this element must be 1, and this element must be 0, and this element must be 1, and this element must be 0. In this pattern, we should convert the LHS as identity matrix. So please here this, the first element is already 1 here, this, no need to convert. And next I should convert the second element, this element. This element must be 0. To become this 0, what should I do? I can take the use of the row 1. This is row 2, this is row 1. So now my dear students, here it is 2. Clear? Now to make this element as 0, what should I do here? It is here already in the row 1 is there. To this one, if I multiply with 2 and subtract here it is minus 2, or else here it is 2 into this row 1 element into 1, I will get it as, here it is, I will get it as 2 minus 2 equals to 0. So like this you should think in your mind, and then you should apply the here it is operation. What is that? I should change the row 2. So therefore row 2 changes to row 2 minus 2 into R1, so that this element will become 0. So therefore my dear students, here it is row 1 is as it is 1, 2. Next here it is row 2 is changing, entire row 2 is you should change. So row 2 is here it is, what is the element? Row 2 changes to row 2. Row 2 as it is, minus as it is, 2 as it is into row 1. In the place of row 1, what is the element? 1. So therefore 2 minus 2 is equals to 0. After writing this rule, once again you should check whether this element is becoming 0 or not. So now it is becoming 0, so therefore here it is 0. Next, my students, this element, apply the here this R2, this rule must be applied to the every row 2. So therefore now apply for here in this particular element. So what is that? Row 2 means here it is. Row 2 means minus 1 minus, here it is, row 2 is minus 1 minus 2 as it is into row 1. Row 1 element is 2. So therefore minus 1 minus 2 2s are 4, and this is equals to minus 5. Clear? Like this we should write. And next, similarly here my dear students, here also first row is as it is 1 0, and second row apply the same rule. What is the rule I applied here? It is R2 changing here it is R2 minus 2R1. So therefore here R2, what is R2 here? It is R2 is 0 minus 2 into R1 place value is 1. So therefore 0 minus 2. Minus 2 into 1 is minus 2. 0 minus 2 is minus 2. This element is minus 2. Next, my students, here R2. R2 is as it is minus 2 into R1 is 0. So therefore 1 minus 2 into 0 is 0. So therefore this is equals to 1. And into A is as it is. Clear? You can observe here my students. Now this element become 1, this element become 0, and now this element must be, here it is 1, because I am converting LHS part as the identity matrix. So therefore this element must be 0. This element must be 1. So when this element will become 1 here, this element will become 1 if you multiply to this element as, here it is already minus 5 is there, to this minus 5, if I multiply with minus 1 by 5, my dear students, this 5 got cancels, minus plus you will get 1. So my aim is to convert this element as 1. So therefore what I will do, I will multiply to row 2 changes to minus 1 by 5 into row 2. To this element I am multiplying with minus 1 by 5 to become this as positive 1. So therefore this implies, so now I write my difference here, apply the that rule. So therefore R2 changing there, minus 1 by 5 into R2. So apply the rule. So to every row 2 we should write that rule. Clear? So my dear students, so there I use that result. So what is that? So next, this row 1 is as it is 1 2. Next, 0 into R2 place R2 element, to that I am multiplying with minus 1 by 5. Minus 1 by 5 into R2, 0, that is 0 only. Next, minus 1 by 5 into minus 1 by 5 into R2. So minus minus plus, that will become 1 here by distance. And next, this is equals to, again here it is, row 1 is as it is 1 0. And next, this is my row 2 is changing, minus 1 by 5 into R2 place minus, here it is minus 1 by 5 into R2 into minus 2. This will become minus minus plus 2 by 5. So therefore here it is 2 by 5. And next my distance, 1 into R2 in the place of R2 I am writing 1. 1 into minus 1 by 5 is minus 1 by 5 into A as it is. Into A as it is. So now this will become here. This will be not at this is up to here, this up to this here 1 2 3. This is becoming identity matrix, but still this element must be 0. Then the LHS will become what is identity matrix. So therefore, my dear students, again I will apply the rule, that is R1 changes to R1. My dear students, R1, this element must be 0. To convert this element 0. So here it is R1 I will write as it is. Now this element I should subtract, here it is. If I subtract with 2, then this element will 2 minus 2 will become 0. So for that reason what I do, R1 as it is minus, to this element I multiply with 2. 2 into R2. Clear? So therefore this will become, see here it is R1 minus 2R2 I am writing. Because if you simplify this, you will get here it is. So now what is R1? R1 is my distance 1. Apply this rule. So R1 is 1 minus 2 into R2, that is 0. So therefore here it is 1 itself. And next here it is 2. R1 plus 2 minus 2 into R2 plus is 1. So 2 minus 2 is equals to 0. So therefore this element I am writing it as 0. Next, row 2 is as it is. We are not changing any row 2. So therefore 0 1. And this is equals to, my dear students, again here it is row 1 itself changing. So row 1 is in the place of row 1 what I have? In the place of row 1 here it is 1 is there. So therefore 1 minus 2 into R2. What is R2 place here? It is 2 by 5. So this will become 2 2s are minus 5. 4 by 2 2s are 4 by 5. Now take the LCM here. It is 1 is LCM. So therefore 5 and 1 LCM is 5. Here I should multiply with 5. Here I should multiply with 1. 1 into 5 is 5, 5 into 1 is 5. So therefore 5 into 1 is 5 minus 4. This is equals to 5 minus 4 is 1 by 5. So therefore here I should write 1 by 5. Clear? Next, my dear students. Next we should solve this one. So 0 minus 2 into R2 is minus 1 by 5. 0 minus minus plus 2 into 1 by 5 is 2 by 5. And this is equals to 2 by 5. So therefore here I will write 2 by 5. I hope you understood. And next, my dear students, the second row will be as it is 2 by 5 minus 1 by 5 into A. Clear? Any doubts? So now we should compare with, my dear students. Now compare with I is equals to A inverse into A. So this is I is equals to, this is A inverse place this element, this matrix is there, A is as it is. So comparing with I is equals to A inverse into A. Therefore, my dear students, A inverse is equals to, in the place of A inverse we have this. Therefore A inverse is equals to 1 by 5, 2 by 5, 2 by 5 minus 1 by 5. This is your A inverse value. Clear? So my dear students, like this you should solve 3 mark, very important. And how I am applying these operations, that way you will come to know if you solve the more number of problems. Please try to solve the more number of problems, then you will come to know how to use the operations. So these type of questions are very important. Many times they will ask such type of questions. So please practice such type of questions. And my dear students, you can apply like here I applied the row operation. Similarly, you can apply the column operation also. But if you are applying the column operations means you should write, instead of writing A is equals to I into A, you should write it as A is equals to A into I. And after that you should apply the up to the LHS, up to convert the LHS as the identity matrix, you should apply the column operations only. And please keep in mind, my dear students, you should not at a time, you should not apply the row as well as column. Row and as well as column you should not apply. You can apply either until it completes the here this. If you are applying the row operation means you should write this and you should apply for fully up to so end of the question you should use the row operation itself. Row operation only you should use. Clear? So like this should solve. And similarly, generally they will ask for two order the matrices of the given order. The matrix here given is of the order 2 cross 2. So please remember, normally they ask for the matrix of the order 2 cross 2. If they ask for the 3 cross 3, then also we should apply the same rule. So here this, the trick is, what is the trick, my dear students? Always you should convert this LHS as the identity matrix in this order only. Clear? And if the given matrix is of the order 3 cross 3 means, in that case, my dear students, if the given matrix is of the order 3 cross 3 means you should write like this. I will show how to write, how to convert the LHS part as the identity matrix. If the matrix if the matrix is generally like this: A11, A12, A13, A21, A22, A23, A31, A32, A33. If the matrix is of the order, given order is of the 3 cross 3, then in that case the similar everything remaining will be same as it is, but only the while converting this LHS part as the identity matrix, in that case please go in this order. First make this element as 1, this element as 0, and next mutations like this, and this like this, and next like this, next like this, and next like this. Clear? First you should make this element as 1, 0. Here it is. What is the identity matrix of the order 3 cross 3? 1, 0, 0, 0, 1, 0, 0, 0, 1. So this element, the LHS part, you should convert 1, 0, 0, 0, 1, 0, 0, 0, 1, and that to be in this order. Clear, my dear students? So first make this element as 1, this element as 0, this element as 0, next this element as 1, this element as 0, this element as 1, this element as 0, this element as 0, this element as 0. In this particular pattern, if you convert the LHS part as the identity matrix, then it will consume your time as well as it will consume your time, and even your calculation part will be easier. So therefore, please try to convert the LHS part to convert as the identity matrix. Please obey in this order. Clear? I hope you understood. So please try to practice the how to find the inverse of the any given matrix. Now, my dear students, I will solve one theorem. You can take it as the theorem or you can take it as the question. So that is the last concept, last question of this topic. So that I am going to discuss. So I hope you don't have any doubts. Please, if you have any doubts, you can comment me. I will reply for that. Please pause the video to note it down. Now we will move on to the next question. That is, the next question I am going to discuss. Either you can take that as the question or you can take that as the theorem. So the question is here, my dear students, if A and B are invertible, if A and B are invertible matrices of the same order, then prove that AB whole inverse is equals to B inverse into A inverse. B inverse into A inverse. So this is the question, my dear students. You can take it as the, either you can take it as the theorem or you can take it as the question. So this is also very important. For 3 marks they may ask such type of question also. Generally what they ask, generally whatever I saw in the previous problem, such type of question they will ask. Generally, normally, on 99% they will ask such type of question only, but remaining 1% they may ask such type of question. So please try to here solve such type of questions, and now I will solve this. So my dear students, what is the condition? What are they given to you? If A and B are the invertible matrices of the same order, then prove that AB whole inverse is equals to B inverse into A inverse. We should prove this result. To prove this result, what I will do, my dear students, I will use the definition of the inverse. So what I discussed, definition of the inverse. In the definition of the inverse, I discussed for the any matrix A. In the previous videos, we discussed, my dear students, here I will use from the definition of here I write from the definition of inverse of a matrix. By definition of inverse of a matrix, what I write, AB whole inverse is equals to, I will write it as identity matrix. Because, my dear students, because what I told in the definition, for any matrix A, if there exists another one matrix B of the same order, such that AB is equals to BA is equals to I. If this condition satisfies, then B we can call it as the inverse of A. B is called as the A inverse. Clear? And what are they given to? What are they told, my dear students? A and B are the invertible matrices. If A and B are the invertible means what they satisfies? A and B are the invertible matrices means obviously here, my dear students, A into A inverse must be equals to identity matrix. A and A inverse, either you can write this instead of B, I am taking it as A inverse. So my dear students, for any matrix A, if you multiply with A inverse, you will get it as the identity matrix. That is the condition of the invertibility. So since they told that A and B are the invertible matrices, being A and B are the invertible matrices, you can say, my dear students, AB you can take here this. If I take the A into B, AB after multiplying A and B, you will get the one matrix itself, you will get the one matrix. Now, if I take the inverse of this AB whole inverse, AB is the one matrix. Again, if I take the inverse of this matrix, again if I multiply these two means, can I get identity matrix only? I will get the identity matrix only, because here, my dear students, if A is the invertible, A and B are the invertible, they given to you. So being A and B are the invertible means what is the condition? Invertible means the condition is for any matrix A is said to be invertible. When you say that A is invertible, A is said to be invertible if to the A, if there exists another matrix A inverse, such that if you after multiplying these two, we will get the identity matrix. So therefore, my dear students, I assume AB is the one matrix I am getting. To that matrix, if I take the inverse of that AB whole inverse, and after multiplying these two, I will get the identity matrix itself. So this is the history. So if you don't want, if you are getting confused with this means, just you can remember, my dear students, for the any matrix A, if you multiply with A inverse, to the inverse of this, if you multiply, you will get identity matrix itself. Clear? So like that, I am instead of taking A, I will take AB. AB is nothing but also, that is also one matrix only, because if you multiply A and B, you will get one square bracket. After multiplying A and B, you will get one bracket, one square bracket only in the element, only within the square bracket, we will get the elements. So therefore, to that matrix, if I multiply with the inverse of that, AB whole inverse, then I will get the identity matrix. So please keep in mind, Just you should remember or you should know that if I to the any matrix A, if I multiply with the inverse of that is A inverse, here A is the one matrix, to that matrix I am multiplying with the A inverse. So if I multiply with that, I will get the identity matrix. So this condition you should remember, and by using that I am writing here this. Instead of taking the matrix AB I am taking AB is the one matrix. Clear? To that matrix, if I multiply with the inverse of that means after multiplying this, I will get it as the identity matrix. AB is nothing but the one square bracket. To this I am multiplying with the inverse of that. If I multiply with the inverse of that, therefore I am taking here this AB is the one matrix into I am multiplying with that AB whole inverse. If you multiply AB whole inverse, after multiplication these two, one matrix AB, to that matrix I am multiplying with the inverse of AB. So if you multiply this, you will get the identity matrix. So therefore, what I am writing, my students, from the definition of the inverse of a matrix, I will write AB into AB whole inverse is equals to I. So after writing this, my students, my aim is, what is my aim? I should prove that AB whole inverse is equals to B inverse into A inverse. So keep in mind, always in the LHS part we should get it as AB whole inverse. So I will keep this AB whole inverse as it is. But my aim is to remove this AB. How should I remove this AB? To remove that, what I will do, my dear students, here A is here. To remove this A, what I will do? Pre-multiply A inverse both sides. My dear students, I am multiplying both sides with A inverse because I will tell you why. Because first I will multiply both sides. You should multiply with pre-multiply means before the elements whatever we have, before the element these elements we should write with A inverse. I will multiply. So what happens? A inverse into A, B as it is, AB whole inverse as it is, and next here it is A inverse. So both sides I multiplied with, here also I multiplied A inverse, here also I multiplied A inverse. Now my dear friends, so if you combine this A inverse into A, what happens? A inverse into A. So again, as I told here this, for any matrix, if you multiply with the inverse of that A inverse, you will get identity matrix. So therefore this will become I into B into AB whole inverse is equals to, and next my dear friends, A inverse into I. For any element, if you multiply with the identity matrix means you will get the same matrix itself. That we discussed in the previous classes. What is that? To the any matrix, if you multiply with the identity matrix, you will get the same matrix itself. So therefore, A inverse into I is equals to A inverse. Since, if you want, you can write here, my dear students, since A inverse into A is equals to identity matrix. Why? Because A is invertible. A is invertible means if you multiply to the A, if you multiply with the A inverse, you will get the identity matrix. So therefore, A inverse into A value is I. And next, my dear students, A inverse into I to the any matrix. If you multiply with the identity matrix, you will get the same matrix itself. Whatever you are multiplying, the same matrix you will get. Clear? So therefore I am writing this. And now my dear students, I come to this point. How I multiplied, pre-multiplying both sides with A inverse. I multiplied A inverse because to remove this A. Now A inverse into A, this will become I. My dear students, and also we know that just only I told to the with the any matrix, if you multiply with the identity matrix, you will get the same matrix itself. So therefore I into B is B itself, and remaining is AB whole inverse. Remaining I am writing as it is. Clear? So I hope now you understood why I multiplied A inverse. I multiplied A inverse to remove this A. This A is removed. Now only remaining is B into AB whole inverse. My aim is to here we should get it as AB whole inverse, and we should remove this B. Again to remove this B, again what I will do? Again pre-multiply B inverse. My dear students, again I am pre-multiplying B inverse both sides. Again I am multiplying both sides with B inverse because to remove this B. So if you multiply B inverse, what happens? B inverse into B, AB whole inverse is equals to A inverse. Here it is B inverse into A inverse. To this matrix I am pre-multiplying with B inverse. Why I am multiplying B inverse? If I multiply with B inverse, this B will go remove and only remaining is AB whole inverse I get. So that is what I have required proof. So therefore I am multiplying with B inverse. So my dear students, next you can write the next step you can write is B inverse into B inverse into B is I itself. Clear? Because B is also invertible. For the any matrix B, if you multiply with the inverse, you will get the identity matrix because B is the invertible. Invertible means the condition itself is B into B inverse is equals to I. So therefore, B into B inverse is equals to I, and remaining is, my dear students, you can put bracket, and next here this AB whole inverse is equals to B inverse into A inverse. Now my dear students, A here it is I into AB whole inverse. To the any matrix, identity matrix, if you multiply with the any matrix, then you will get it as the whatever you multiplied with to the identity matrix, the same matrix you will get. So this therefore I into this is IAB whole inverse is equals to B inverse into A inverse. This is what your required proof. So like this you should solve. So this is also very important. Sometimes they may ask such type of questions. Clear? So please pause the video, then you can note it down, and still if you have any doubts you can comment me. I will reply for that. Clear? Next, my dear students, another one note you should remember. The note you can remember, or you can take it as theorem and you can solve yourself. What is that? For any matrix, for any square matrix, or you can take for any square matrix A inverse is unique. So what is that? For any square matrix, if you take any square matrix A, if inverse exists, then that is A inverse is unique. For any matrix A, if there exists an inverse, means that is a unique. For any, that the meaning is for any matrix A, for any square matrix A, there exists only one inverse, one matrix inverse exists. For any matrix there are no more than one inverses are there. So for any matrix A, if you take any matrix A, there exists only one inverse. That A inverse is unique. If it exists, then that is a unique. Clear? I hope you understood, my dear students. And now this completes your matrices topic. So this is your matrices. Whatever we discuss. So this completes your matrices topic. Clear? And still some more maybe the questions may be there. So please try to solve the exercise questions, and remaining questions try yourself. Still, if you have any doubts, you can comment me. I'll solve that one. So I hope you understood. And in the next class, we will discuss the next fourth topic of your NCERT syllabus mathematics, that is determinants. We will continue in the next class. Thank you.